హలో గైస్, ఈరోజు మన టాపిక్ వచ్చేసి ద మోస్ట్ ఇంపార్టెంట్ టాపిక్ సెపరేషన్ ఆఫ్ లాంథనైడ్స్ బై అయాన్ ఎక్స్చేంజ్ మెథడ్. సో దిస్ ద మోస్ట్ ఇంపార్టెంట్ టాపిక్ ఫర్ MSc and BSc students. So first of all I will give explanation to how to separate the lanthanides from by ion exchange method, then I will give notes. Okay, now the first point is this is the lanthanide series, and this is the ionic radiation for a diagram. So this is the most important topic, and lanthanide series సంబంధించి మనకి డిస్క్రిప్షన్లో లింక్ ఇచ్చాను. ఎవ్రీ క్వశ్చన్ అండ్ ఆన్సర్స్ మన డిస్క్రిప్షన్లో లింక్ ఉంది, చెక్ చేసుకోండి. ఏమైనా డౌట్స్ ఉంటే కనుక కమెంట్ చేయండి. సో ఫస్ట్ ఆఫ్ ఆల్, so nowadays lanthanides are exclusively separated by this method. So the basis of the lanthanide series separation exchange column ion. So here first point is all lanthanides are plus 3 ions. So all the lanthanides, here this is the first example, first explanation I will give from diagram. So all the lanthanides are plus 3 ions. సో ఇన్ దిస్ డయాగ్రామ్, సో బిఫోర్ ల్యాంథనైడ్ కాంట్రాక్షన్లో చెప్పాను, అది కూడా ఒకసారి చెక్ చేసుకోండి. ఫుల్ క్లారిటీ వీడియో ఉంది దాంట్లో, డిస్క్రిప్షన్లో లింక్ ఇచ్చాను, చెక్ చేసుకోండి. ఇన్ దిస్ ఆల్ ద ల్యాంథనైడ్ ఆటమ్స్ ఆర్ ప్లస్ 3 ions. ఇన్ దిస్ డయాగ్రామ్, when atomic number is increases, this is the atomic number 57, 58, 59, 60, 61 up to 71. So lanthanum to lutetium, when the atomic number is increases from lanthanum to lutetium, the ionic radii was decreases. This is the ionic radii. Ionic radii 105 to 100, 95, 19, 85 from lanthanum to lutetium, 105 to 85. So first point is when atomic number is increases, ionic radii was decreases progressively with increasing atomic number from cerium to lutetium. So lanthanum is no F element, so we have to consider from cerium to lutetium. When the atomic number, ionic radii was decreases when atomic number is increases from lanthanum to lutetium. That is the first point. All the lanthanums are plus 3 ions, and when atomic number is increases, ionic radii was decreases from lanthanum to lutetium. In this, as a solution containing, here second topic is from this diagram, when the solution of lanthanides containing Ln plus 3, that means lanthanum ions are plus 3 ions charge. So as a solution, this is the solution containing plus 3 lanthanide ions is placed at the top of the column. So this is the stationary phase. This is like chromatography system. So we have to take the stationary phase. In the top of the column, lanthanum liquid solution is there, Ln plus 3. So this all the lanthanum solution is there. When the lanthanum solutions are poured into stationary phase, ఎప్పుడైతే ల్యాంథనమ్ సిరీస్లో వెన్ ద పోర్ ద ల్యాంథనమ్స్ ఇంటూ స్టేషనరీ పేస్, సో ఇన్ దిస్ lanthanum plus 3 ions are absorbed into the resin. So what is resin? Resin means resin two types, cation exchange resin and anion exchange resin. So when the solution of lanthanides Ln plus 3 poured into stationary phase, here resins is there. So what resin you have to take? Lanthanum are plus 3 charge. So plus 3 means you have to take cation. So resins have cation exchange resin and anion exchange resin. So lanthanums are plus 3 charge, so that means plus, that means cation. You have to take the cation exchange resin, that means example SO3H and COOH is the example. So this is the lanthanum solution. This is the resins we have to take in stationary phase, that means SO3H or COOH we have to take. When pour the lanthanum solution into stationary phase, this cation, when H plus SO3 minus, SO3H తీసుకున్నాం, అది How it divide SO3 minus H plus. H plus is the cation. When this cation, that means H plus is rearranged to lanthanum or replaced to lanthanum. This lanthanum is rearrangement to or interact to this SO3H plus. So this is the reason you have to take. So second point is when the lanthanum solutions are poured into stationary phase, this SO3H, we have to take the SO3H. This SO3H, in this H plus is cation, this H plus is rearranged to observed or observed to lanthanum ions. So these lanthanum ions are observed to the cations, that means resin. So equivalent hydrogens are released from the column. That is the second point. And the third point is so when these resins are rearranged observed to lanthanum, these resins are observed to lanthanum ions. Now we have to separate the these resins from this column. This is the column. So these resins we have to separate from the column. So now we have to take the buffer solution. So buffer solution, you have to take citric acid and ammonium citrate. So we have to divide, or we have to remove, or we have to separate. So we have to separate this resin from this column. So now so we have to take the citric acid or ammonium citrate. So this is, that means equivalent you have to pour like this. That means what you have to take buffer solution, citric acid plus ammonia acid. When you pour the citric acid or ammonia acid into the stationary phase, now here happen to here how to separate. That means here lanthanum elements means lanthanum, cerium, praseodymium, neodymium, promethium. From lanthanum to lutetium, lanthanum is size is big size, lutetium is size is small size. That means lanthanum is big size. Big size means up untundi. So lutetium is small size. So here lanthanum, lutetium, cerium, praseodymium, promethium, so up to lutetium. So what is you have to separate easily? That means lutetium is the separate you have to easily. So lutetium is separated easily from the column. Since the smaller ions, so smaller ions have showed greater preference for complexing with the citrate solution. Those ions are the first emerge from the column. So smaller ions are easily separated from the column. Larger ions are after the smaller ions. This will be take some time. So now which one is separate first? So small size means, that means lutetium. By the correct choice of the condition, lutetium emerges the first from the column, followed by the cations ytterbium, terbium, dysprosium, holmium, like that. So first one is lutetium, next ytterbium, terbium, erbium, holmium, dysprosium, terbium. So like this we have to separate the smaller ions first, and big size is last. So small in size, that means small size less hydration. Small size is less hydration comes first. Big size is more hydration comes last. సో దిస్ ఈజ్ ద ఎక్స్ప్లెనేషన్. అండ్ నోట్స్ కూడా నేను ఆల్రెడీ థియరిటికల్ రాసి పెట్టాను, దెన్ యూ కెన్ చెక్ ఇట్. సో ఇక్కడ కూడా మనకి ఉంటుంది. సో నౌ యూ హ్యావ్ టు రీడ్ లైక్ దిస్: సెపరేషన్ లాంథనైడ్స్, ఆల్ లాంథనైడ్ ప్లస్ 3 ions. ఇక్కడ నేను ఏదైతే చెప్పానో అది మాత్రమే ఇక్కడ ఉంటుంది. సో ఈజీగా నేను చెప్పడం కోసం హియర్ చూడండి, లాంథనైడ్ ప్లస్ 3 ప్లస్ H ప్లస్ ఆర్. యూ హ్యావ్ టు సపరేట్ ద H ప్లస్ అండ్ క్యాటియన్ ఎక్స్చేంజర్. దెన్ సిట్రేట్ బఫర్ తీసుకున్నాము. వాట్ ఈస్ ఫస్ట్ రిమూవింగ్ ఫ్రమ్ కాలమ్ అనేది, అండ్ దెన్ నెక్స్ట్ సిన్స్ ద స్మాలర్ ions షో. సో దిస్ ఈస్ ద ఎక్స్ప్లెనేషన్ హియర్. దిస్ ఈస్ ద నోట్స్, దెన్ యూ కెన్ చెక్ ఇట్ అండ్ సబ్స్క్రైబ్ చేసుకోండి, మీకు వీడియోస్ కనిపిస్తుంటాయి. థ్యాంక్ యూ గైస్.